Okay, so I guess I'll start. So first, I'd like to say thank you for attending. It means a lot to me, and I'm definitely excited to be here. This is my first LambdaConf, so I haven't been to a programming conference like this before. I've already learned a whole lot and totally got my ass kicked yesterday, so much that I had to just kind of give up, but I still actually learned something, so I consider that a positive. So I hope to have a lot more fun here, and I hope you're all having a great time. So my name's Phillip, as you can tell by my slide, and I work for Microsoft, as you can tell by my slide. I work kind of on all things Fsharp, language design, compiler, core library, tooling, especially tooling inside of Visual Studio, documentation, some various evangelism efforts, but not a whole lot. And I also work on the Fsharp Compiler, but I'm not going to talk about that here. So I called this "You Got FP in My Enterprise," or "You Got Functional Programming in My Enterprise." And this isn't really a talk about how to get functional programming in your enterprise, so much as it is a bit of a case study of what functional programming in one of the largest enterprises in the world looks like. Microsoft being 130,000 employees, the size of a small city. There's a lot going on in that sort of thing. And just because I think you can get functional programming into a workplace or a big enterprise environment doesn't mean that you can succeed in keeping it there. And there's a whole lot of factors that go into what people care about over time in massive organizations that oftentimes have little to do with functional programming, but it's still something that I think we have to care about. Otherwise, people are just gonna, as time goes on, start introducing things that are not functional programming that might overtake the things that we initially got in there. So I want to start actually by talking about Fsharp the language and kind of how most people, especially like the users of Fsharp, see Fsharp, because I want to sort of use that as almost as a thing to contrast against later on in the talk, because I'll spoil it for you. The way that most people view Fsharp the language is really not how we view it at all when we're actually producing Fsharp the language. So there's kind of three major ways that you can look at it. The first is it's the ML, or Hindley-Milner style language. It's cross-plat, open source, like the others. It's got functions, values, and function values, like the other ML languages. It's immutable by default. You can opt out of that if you need to, like this beautiful example right here. And it supports currying and partial application, so you can do some pretty fancy little code reuse things. You can get very elegant in how you compose things, and that's pretty par for the course if you're familiar with ML style programming already. There's also a bit more, type inference, pattern matching, record types, like what we have up there, this full name type that's composed of a first name and a last name, discriminated unions, which are just union types, and you can stick all sorts of stuff inside of those. That's your sum types. And we also have anonymous records, which are relatively new, but I'm hoping are kind of the mainstay of the Fsharp programming language, where you can just define a record type ad hoc and stick it where you need to. In fact, this definition right here would not be possible without doing some, I think it's mutually recursive type definition to basically state that an employee depends on a record type. And yeah, actually, it's something like that. There's various ways that you can do that. And yeah, it has significant white space by default, which I think is slightly unique compared to other MLs. Some MLs are much more similar to Visual Basic in that regard than they are, with the little begin end blocks and that sort of stuff. I much prefer that to Visual Basic though. But we took the Python route, I guess, of having significant white space. But it's also a .NET language, which is, I think, where it starts to differentiate itself more from other ML style programming languages. It ultimately uses the .NET object system and the .NET generic system. That's just inherent to the design of the language, and that's just something that bubbles up kind of in everything that you do. It's got reference types and value types. So that full name record, I can actually make that a struct, and depending on the kind of data that it has, it could either live on the heap or the stack. It's got classes, abstract classes, interfaces. Typically, you'll use interfaces a lot as Fsharp being a .NET language, but not really the classes, abstract classes as much. In this case, this is kind of what it could look like. There are also inheritance and null pointers, sadly, but that is just the reality of living on top of a runtime that has these concepts. And so to be able to properly interoperate with things that are also running in that runtime, you need to be able to do these. Now, we definitely de-emphasize the use of inheritance. We typically deny any kind of feature requests that have to do with inheritance, because we just don't really, like, we want to have it be this thing that you just have to use, not something that you want to use. And similarly with null pointers, you have to actually go to great lengths to introduce like a null literal as a value inside of Fsharp code. There are various mechanisms you need to do to actually opt into nullability by default. However, if you are interoperating with a .NET component where they pass nulls in, you still have to account for that. And that's something that we're looking to address later by introducing nullability for reference types that I'll briefly talk about. Well, reference types from metadata that I'll briefly talk about. But that's just, it's the reality of being on .NET, and I guess that is a little bit unique compared with other ML languages. And you can do some pretty cool high performance, low allocation programming because of being on .NET. So you might be looking at this and no, this is not me just trying to flex or anything like that. This is just the fact of .NET being an excellent runtime that gives you extremely good CPU perf. And you can really reduce your allocations too if you're on .NET Core by using a particular kind of value type called a biref-like value type that guarantees that nothing will actually be allocated on the managed heap. With that comes some trade-offs in programming, and we tried to document it as best we could, but it's actually a bit of an impedance mismatch between Fsharp, the functional language, and Fsharp, the .NET language, but it's still cool because everybody likes good perf. And the other important thing that I want to call out is by being a .NET language, you can consume any .NET component in Fsharp, and you can produce a component that other languages in .NET can consume. So that's, I think, a very important thing from an adoption standpoint, because if you're working with a larger C# code base, you can't just be this thing that it can't talk to, because you're never going to be able to get anybody in your workplace to, approve the use of Fsharp in that way. I mean, I guess maybe you could communicate over HTTP or something, but like that's not going to be every single circumstance. So, but there's also Fsharp, the unique language. Because Fsharp does a few things that are a little different than just being on .NET or just being a Hindley-Milner style language. Type providers are pretty sweet. You can point the compiler in an arbitrary data source and you can generate types from that, and you can bubble that up into tooling so that you can do things like write code where you no longer have an assumption about the underlying data. You actually have a strongly typed relationship between the underlying data, and as the underlying data changes, your code will now start to fail to compile. That has certain trade-offs. It can be good or bad depending on what you're after, but still pretty cool. There's active patterns, which if you're familiar with Haskell view patterns, that's basically what active patterns are, but they do things slightly differently. Units of measure are a way to apply a little bit of type safety to numeric literals, which are very helpful for scientific compute sort of stuff. Fsharp code quotations allow you to extract typed or untyped Fsharp syntax trees and manipulate them for like kind of a limited form of metaprogramming. It's not like metaprogramming mecca or anything like that, but it's still pretty sweet. Object expressions are a way that you can implement interfaces in an ad hoc fashion that helps with .NET interoperation. And computation expressions, which I have an example of right here, are a general purpose mechanism for effectively creating DSLs. Now, they are typically used in things like contexts like monadic error handling or composing, asynchronous computations monadically or something. But they're not just a tool for monads. They are a tool for doing things kind of in a totally general purpose way like this. This is all about creating a web application. And every single one of these has a concrete definition that does something kind of cool. And so you can write a lot less code to have something that's fairly robust. And in fact, I don't have an example of this, but you can actually write a computation expression that violates every monad law. So you can sort of have like an anti-monad, if you will, that looks kind of like other monadic stuff in Fsharp. So that's unique, although I wouldn't encourage you to actually do that. So this is all fine and dandy, but this thing not, there we go. But we don't really view Fsharp that way internally at Microsoft. I mean, I'm sure some teams do. Like, Fsharp is used heavily at Microsoft Research for research projects. There are a couple of actual products inside of Microsoft that use Fsharp, like OneNote. They have like a sync layer between all sorts of current and legacy systems, and that's all written in Fsharp. We actually have a service that's basically fuzz testing as a service in our cloud, and that's also all written in Fsharp. And I think there's some anomaly detection inside of Azure that's also done in Fsharp. And like, all of that stuff that I talked about, they use all that, and I'm sure they have a mostly good time. But on the team that produces Fsharp, we don't really think about these things that much. We use certain elements of what I just talked about from time to time, but we don't really go about coding like, oh, we're doing our Hindley-Milner style type inference right now as we're producing this product. Like, that's just not a thing that happens. So I want to talk about the things that we do care about, kind of in hopes that there can be some sort of learnings that you can extract, either as people who are involved in language evolution, or just component design, just libraries and things like that. And maybe you can adopt similar principles, and that could potentially help you either introduce things to the enterprise or keep something in a workplace once you got it there. So the first thing we think about, obviously, is the Fsharp compiler. It's kind of an important one to think about. It's written in Fsharp, it's a single code base, but we package it in 4 different ways. We have a binary distributable for .NET Core. We do source builds so that everywhere you don't have a binary distributable, you can actually build it if you'd like. We package it up for .NET Framework for the old style .NET on Windows. And we also package it up for Mono, which is kind of old style cross-platform .NET that frankly not a whole lot of people like using. But we still support it because there's legacy code that runs on that, so we want to make sure that they can get compiler updates. It supports Fsharp source and script compilation, where scripts are similar to Fsharp source, but they have a few additional directives that you can apply that modify your semantics a little bit, let you reference things slightly differently than you would as a part of like a normal project. It's hosted as a server process for tools, where each of the compilation phases are exposed as an API that get used by tools, which I'll talk about more later. And we also emit what are called PDBs, or programmable databases. And these are files full of metadata associated with your code that basically determine if something is to be considered debuggable, so that a debugger can plug in and so it makes sure that when you're debugging it can like break on the correct expressions and that sort of stuff. The PDBs are actually used by the Fsharp tools to sort of do like a spot check of, okay, we think this expression is debuggable. Is there a thing it's called a sequence point? Is there a sequence point in the PDB file that corresponds to this expression? Yes or no? And if the answer is no, then that's kind of a problem. You can't really debug it. So we make sure that we do that. And last point, backed by an enterprise SLA, arguably one of the most important points. Just last year, we were working with an escalation engineer to help a customer who was using Fsharp 2.0, which released in 2010. Their build server was no longer working because they couldn't compile. And we're like, that's a problem. We haven't touched Fsharp 2.0. So I don't know why that's happening. So they had an antivirus vendor who they talked to, and they were saying, oh, well, the Fsharp compiler is malware. That's why you can't compile. So we're like, I mean, I wasn't around in 2010, but I'm pretty sure we didn't explicitly create malware. But so we worked with them for about a week and resolved it, and we got the antivirus vendor to make a change. but that's what an enterprise SLA gets you. And that really, really matters if you are a multi-billion-dollar bank who depends on a compiler to have your core business work. So it's important to have. We also do the Fsharp Core library, which is called fsharp.core. Very clever name. Also implemented in Fsharp. It has some fundamental constructs. So there's the .NET type system that we use. Well, we have some more Fsharp-friendly variants of that makes it nicer to work with. Mathematical operators, some little equality constructs, because if you dive into the depths of .NET, you'll find that equality is actually kind of difficult. So try to make it a bit easier. We have a couple of collections and data types that are very well written, and we try to make them as efficient as possible. And there's arrays, lists, sets, maps, 2D arrays, all that sort of stuff. Option, value option, results, choices. It grows a little bit, but not a whole lot. We try to keep it, a core that's very, very good. And we have a lot of built-in functions so that you don't have to go and write a whole bunch of functions for doing things just like list processing. And we do a lot of native interop stuff, so that if you need to interoperate with some C++ binary running on your Linux server somewhere, you can actually do that. And you can do it in a way that's hopefully pretty type safe. We also do Commandline Tools, implemented in Fsharp. It's a theme. This is primarily, the biggest one is Fsharp Interactive. It's a REPL that allows you to execute Fsharp scripts, or in the case of the screenshot right here, just kind of Fsharp code entered in line. It has some cute color eyes. colorized stuff, which is kind of nice. But actually, another thing that it does is it has a pretty printer for arbitrary values and F# constructs. So we think that that's a pretty good learning tool for people who are kind of new to the language. And there's also build tooling that ties into .NET build tooling that we got to make sure works. There's also F# editor tools as part of the F# product. Again, implemented in F#. This one also backed by an SLA because it's Visual Studio. I don't think we've actually had a case yet of a customer telling us that we had to fix like a tooling issue yet, but if they were to do that, that's probably the first thing that we would prioritize because, again, backed by an SLA. Important distinction here between other languages, and I think most functional programming languages, is we don't have a tooling compiler that has subtly different semantics between that and the actual compiler. It's the same compiler because we cannot imagine living in a world where you have a lack of an error in one but an error in the other, or vice versa. Like, that's just kind of insane. So, and a whole bunch of different features, like got some neat little tooltips, some analysis that happens on documents and provides code fixes, find references. There's a whole bunch of different refactorings and things like that. So, auto-completion, varying forms of auto-completion. There's also F# editor tooling in Visual Studio Code if you're not on Windows, because we care about cross-platform. This is not directly authored by us, but this does use the exact same compiler and language service as what lives inside of Visual Studio, so it is sort of transitively supported the same way that Visual Studio is, at least as far as anything that's inside of the compiler or the compiler service. This is an open source project that has about 1.3 million downloads, so it's pretty popular. People like it. They like it for good reason because it's really good. And it has a similar feature set to Visual Studio. It's just, there's certain scalability things that can be better in a fully fledged IDE compared to this, but this is fine because for scripting, small to medium-sized projects, this is a wonderful tool, so I encourage you to check it out. And even though it's an open source project, we are actually funding it by paying the main contributor full-time because it's used by a lot of F# developers, and the intersection of people who use Visual Studio Code and Visual Studio for F# development is very small. So there's distinct groups, both are growing, and we want to support both efforts. We don't just want to do the one that has the Microsoft name on it. So, lastly, F# documentation is a big part of the F# product. I think this is one that is particularly lacking a lot in the functional programming community. I think although there's certainly a lot of truth to the fact that depending on what you're doing, the type signature is enough, I think realistically a lot of people try functional programming and immediately give up once they find that there's no nice guides telling them how to do a few things, and eventually getting to the point where they could just look at the type signature and be able to reason about what's going on. So we got a full language reference, style guide, various tutorials. I think the language reference, there's one piece that's missing before it's fully up to date. I need to finish up an anonymous records document, but that's sort of that. And we make sure there's lots of sample code and tutorials there so that people can at least feel like they can get started with the language and not suffer too much. So that's a lot. That's compiler. I didn't even talk about the language design aspect yet, but this is a lot to keep track of. And there's a whole bunch of features through all this. You can think of documentation as varying features, that sort of stuff, but actually none of these are our biggest feature. Sort of there's one thing that sort of holds all of this together, and that's where we spend actually all of our time, and that's compatibility. So compatibility is actually the biggest feature the F# language has. At least it's certainly the one that we spend the most time on. So the language is backwards compatible. Anything that would introduce a breaking change is immediately ruled out. We don't care. It could be the most elegant way to express something, but at the end of the day, if it breaks somebody, we don't do it. And that's just that. This is an example for the nullable reference type thing that I talked about earlier, because in .NET, take string, for example. Well, today, string is not string. It's implicitly a union between string and null. But you don't get compiler analysis to tell you that. So we said, okay, well, if it's a union, well, we already have discriminated union syntax with the little thingy right there and the little bar and the other little thingy. So we're like, okay, cool. Well, we'll put that in type signatures. That seems like that would fit with F#. But it turns out there are valid F# programs. There's this function. You could write a program that just calls this function. That's totally valid today. It's kind of nonsense. But when you're operating at the scale of having customers with hundreds of F# engineers or millions of lines of code out there, every single little edge case exists and is depended on. And so this little toy program may actually be somewhere out there in one of our customers' code bases, just running fine. And if they decide they're going to update their compiler and hit build and it fails, they're not going to be very happy. So we try to avoid that as much as we can. And by that I mean we actively deny things that are not backwards compatible. And this is also something that we don't figure out immediately. Like, we wrote about 10,000 words in the spec for nullability analysis and what that all meant before we came to the realization that there was actually a breaking change, and we had to go back and redo the syntax section. And we arrived at a question mark, which is what C# is going to do. And that was actually the one that we didn't want to do the most, because we didn't want it to look like C#, and we frankly just kind of hate the idea of having question marks everywhere. But we got to be compatible. You can't break string. So the compiler core library are also binary compatible. The core library is sort of the big one. Every single type, function, and member that sits in there is stable, and it's stable across versions. So if you're on an older compiler and there was a Fsharp.core binary that was produced by a newer compiler, you should still be able to consume that. Now, it's not forwards compatible, which is a slight distinction. That means that we don't have a moratorium on any construct that an older compiler could not understand, right? We're allowed to put new types in there that an older compiler might not get, but we can't mess with the existing stuff. So that means we can certainly introduce new concepts, and we do. But once we've introduced them, they are solid, they are concrete, they do not move. If anything changes and there's a binary compat problem, it's an extremely high priority fix. We push up an update to the package where this thing lives on NuGet, and we unlist the older package immediately. That allows most tooling to never pick up the older package ever again. And we try to blast out to everyone, hey, there was a problem, okay, now you can update and things should be fine. That being said, some things are not supported because you can't go too crazy with compatibility. .NET supports reflection. And with reflection, you can reflect into the internals of any component. That is not supported. If you reflect into the internals of how the compiler or core library work, and you take a dependency on that, sorry, but we do reserve the right to break you, because that would be insane for us to actually, support that. Similarly, with the metaprogramming stuff with code quotations, if you rely on the structure of a syntax tree, that is also something that's not truly supported. Now, we go to a great lengths to make sure that we try to keep that as stable as possible. But we do have to reserve the right to be able to change our internal representation of our syntax tree so that we can do things better. And if you create quotations that use the old structure and that breaks, well, sorry. We'll work with you to figure it out. And anything, I mean, this kind of goes without saying, but anything we explicitly mark as a bug that is some behavior that you take a dependency on, we're going to fix that bug eventually. So you probably don't want to do that. And then any deprecated construct or deprecated way to use a construct is not supported. And so speaking of deprecation, we do deprecate things. But we have a very specific way of doing it. We don't release something and break you. We release something and we do a soft deprecation where we emit warnings, not errors. Even though we don't want you to be doing this thing at all, we still do it. We still do warnings and allow you to compile. And there's an attribute in .NET called the obsolete attribute that we apply to things if we can. Eventually, we do hard deprecate, but that goes through multiple releases. So we want to have at least one release where something has been soft deprecated and has been emitting warnings, and sort of letting you know that, hey, you shouldn't be doing this. And only then will we start the process of actually killing something off. And at that point, this is when we say, okay, we're going to hard deprecate this thing that we soft deprecated. That's when we start really working with the open source community to identify, okay, what are the top components that are going to be affected by this, if they are going to be affected, and what can we do to help them move forward so that anybody, people can control their own code base, but they can't necessarily control their dependency graph, and we want to make sure that their dependency graph isn't a problem. And we communicate this over years. So we try to do the soft deprecation well in advance. We do the hard deprecation, sometimes multiple releases after the fact. We have a couple of things that have been deprecated softly for a couple of years now, and we still haven't even begun the process of hard deprecation. But we will eventually, and we're going to communicate that and document everything, because although we can't guarantee that nobody will be broken as a result of doing this sort of thing. We can at least guarantee that we have a paper trail so that somebody who's angry about the fact that Microsoft broke them in some regard can take a look and go, oh, they were planning this for a long time, and I didn't know that, so okay, at least they communicated up front about it, so I can't be as angry at them. At least that's the hope. That being said, we fucked up. Fsharp 4.5 was actually a great release. The problem wasn't Fsharp 4.5, it was Fsharp 1.0. The managed pointer type that existed for a long, long time was actually broken. Oops, I wasn't there for that, so I take no blame, but that was a thing. And one of the big goals of Fsharp 4.5, aligning with some of the .NET investments around high performance, like getting those nice numbers that you saw earlier, you couldn't get those unless we fixed the broken semantics for managed pointers. So we had a hypothesis, which was that, okay, the semantics are broken, so probably most people aren't going to be depending on them. But it was kind of terrifying because we said, okay, do we enable something that pushes F# further and allows F# to be distinguished amongst other functional languages as being great for performance? Or do we keep something to be something broken for compatibility's sake? It's a very difficult decision, and it scared us a lot. Because we actually had never been in the situation where we had to outright break something. So we eventually did, and we got lucky, but that was kind of terrifying. Like, we had multiple meetings where we were just like, okay, let's develop all these contingency plans, and luckily it was all for naught. We didn't have to do anything. Now, granted, we did work with open source authors who were using managed pointers, and we got them to update a few things and things like that, but that was a terrifying time, and so we actually are introducing a new concept that isn't too crazy, but it's like the right thing to do in hindsight, but just never existed in F# up until this point, is a language version flag, where there's a particular evolution for how things go into a language version, and there's an implicit language version that's implied by any new project with certain tools, but the main thing is we want to be able to evolve, and we want to be able to do things like soft deprecate and eventually hard deprecate, but we want to give people at least a tool to back out of some of that stuff, but still have an updated compiler with bug fixes, performance improvements, all that sort of stuff. This also allows us to get new features out behind a preview flag into a released compiler significantly earlier so that we can vet our designs a lot earlier, because we do, all the language design is open source and on GitHub, but that's still a limited group of people. It's not going to be all possible F# users, and so we want to make sure that we have at least a way for some people who aren't engaged with us online to try things out and file a bug that says, hey, I don't like this, and even if it's not actually a bug and we have to close it and we say, no, that's by design and you have to like it, at least we give them the opportunity to do that. So there's another tool for compatibility, our biggest feature, and that's being very conservative about how we actually evolve the language. So F# has a lot of features, has a whole lot. Some people in the F# community think it's too many. Some people in the community think it's too little, so can't really win. And a lot of features get requested and ultimately denied, and we get punched for that, basically. People don't like it when you deny their language request, because people usually have a good reason for requesting something to be in a language. And we sort of have a process where the guy who created it, Don Syme, he's ultimately like the final call on if something gets in or not. And we try to be as democratic as possible, but at the end of the day, we do have to manage our own complexity. And there's this ever-growing multi-dimensional matrix of this feature, working with this feature, working with this feature, and everybody expects it to all work. Everybody expects it to all be the same as the language evolves, and it is strictly impossible for us to keep this all in our heads. Like, that matrix is just enormous, and aggressively adding more features just means we're going to be adding more opportunities to screw up. So this one at the bottom, I actually closed this morning. This is actually, so this record types based on other record types, this is actually an inheritance feature. This is effectively, they said it was an inheritance, but they actually wanted to be able to inherit one from a record so that they didn't have to, they had records A and B and they had similar labels, and they said, oh, well, I want to sort of absorb the labels from one and then just have additionals in the other. Well, the problem is that's inheritance, so we discourage inheritance, and there's a rabbit hole of problems that come with introducing inheritance with F# record types today that we just said, nope. I like this right here. This sort of shows you some of the problems that we run into here, where someone says, I think new shorthand notations in the language never bothers anyone. But then Don Simon replied, well, they increase the cost of the language, and if people in your team don't know the syntax, then team cooperation becomes harder. So although I think it's fair to say most people are fine with nicer ways to express things, they do indeed come at a cost. And from our perspective, we have to make sure that both approaches still work. So any additional shorthand is sort of just an additional way to do things, and it's more of a tax. And we labeled syntactic macros as probably not. We didn't outright deny it because there's a chance, a very fleeting chance that might exist, but I don't think it's going to happen. So this is one of the most powerful tools for managing compatibility. I think that kind of goes without saying, but if you take the approach that compatibility is your biggest feature, then you can't be too aggressive in language evolution. That being said, we are adding like 6 new features later this year, so hey, so we're not too conservative. We try to strike a balance. So that compatibility is the biggest thing that we spend our time on, but we also spend a lot of time on performance and how it relates to functional programming. And I think this might be a little bit interesting, especially if any of you are working with .NET or had worked with .NET, and you're kind of interested in how the functional sides of F# work on that. And I'll be honest, sometimes they're a little bit at odds with each other. So currying and partial application are not free. And that's because of the way that .NET works. If you want to represent a higher order function, it has to be heap allocated. And that's it. There's no ifs, ands, or buts about it. It has to be that way. That implies that actually all F# functions are heap allocated. All parameters to higher order functions get heap allocated. Partially applied functions have to be unique functions that are heap allocated. And all Lambda expressions are heap allocated as well. It's just because we don't really have a difference really between Lambda expressions and functions. They're the same thing, right? So point-free and heavier use of partial application, like that comes at more of a cost. And so as an example here, if you look at the top left, this is the one that I showed earlier, that little trivial sample there of just, this creates a function value called getOddSquares. And the bottom basically gives you the same result, but it's a function that takes an explicit parameter. The bottom one allocates 40% less stuff. And that's because the list.filter is odd thingy and the list.mapSquare thingy, if you actually look at what it gets compiled into, those are distinct functions that are allocated, whereas these guys right here have already been allocated. So we have to basically create a partial function, and we have to, that's sort of like a soundness thing, right? When you compose these two things, you have to create these distinct things and then compose them through a well-known form. There might be a way to optimize that, but you might also lose some soundness as a result, and we don't really want to be losing soundness in a functional programming language, because that's kind of one of the whole points of functional programming is soundness in your code. So there's some fallout of that, which affects the compiler for sure. We just don't really use partial application very much. It's just what we don't do. Now, that being said, the allocations aren't necessarily horrible. Like .NET was designed for you to allocate stuff. Just the way that the JVM is designed for you to allocate stuff. So it's not this inherently bad thing. In fact, the .NET GC can handle 10 gigabytes per second of cleaning stuff, which is, we built a little stress test and it handles it. Now it creates some CPU time doing so. Like your CPU fans are going to be going by cleaning 10 gigabytes per second, but it's good. It's very good. And especially when you're just doing batch compilation, like via command line or something, that it honestly doesn't really matter that much, because you have your process for compilation, it does its thing, and then your process dies because you produced your artifact and you're done. All right, the GC cleaned up the stuff, it's fine. Not so fine later on. I'll talk to you about that. Another aspect of performance is static constraints. So this is sort of how you do ad hoc polymorphism in Fsharp, and you can actually do sort of higher kind of type encodings that way. But it will torture the compiler, so we don't use it inside the compiler. And that's because the .NET runtime has no notion of, oh, this type has this static member X. That's not a concept that the .NET runtime understands. So the compiler is forced to solve all of those constraints and optimize them. Whereas there are other constraints that it can support that are not static constraints. Those the runtime can understand, so those we can just forward right onto the runtime and say, hey, you're the best at optimizing this thing, so go ahead and do it. So we try to avoid static constraints. We don't really do much ad hoc polymorphism in the compiler. It exists in the core library for definitions of operators and a couple of other things like that. But as far as like architectural strategies go in terms of like implementing a type checker or something like that, we don't really use it. And that matters, especially as I start talking about editor tooling performance. Because, as I said, we don't have a tooling compiler. We have the compiler, and that is hosted as a server process. So all that allocation stuff that I talked about, now it becomes a big problem, because rather than having a process that spins up, does some work, and dies, this process can live potentially forever, so long as you keep your machine on and your editor open, right? So, especially if you allocate large objects, which are 85 kilobytes or higher, the way that the .NET the .NET runtime works is if you allocate very large objects, like pretty decent sized arrays, those get thrown on what's called the large object heap. And when the large object heap gets collected, every single thread in the process has to pause. That's just an architectural decision by the .NET that we have to live with. And this becomes a problem a huge problem, right? If you have an editor where you host the compiler in the same process, that causes a massive UI freeze, potentially a really long one, depending on how much stuff has to get cleaned. Even if you have stuff in a separate process, freezes that process. So even though your editor process might be responsive, you're entering commands and you're getting no feedback from that when you would normally expect to get feedback. It's kind of a big problem. So dealing with this is a talk in and of itself, because the architecture of how we handle this is a bit intricate. But at a high level, we actually do use OOP here. We use objects because objects, they're all about, okay, I constructed this thing that has a lifetime, that I can tie to the runtime, that I can hold data inside of, that I can have members that can access that data, but I can hide that data from, that is probably one of the good parts of OOP, and so we try to use that. We don't really mix it much with functional. We pretty basically say, okay, it's .NET methods are accessing this stuff. We're not going to create additional overhead for functions, so we're just going to do that. We do actually use modules of functions, and we do have, plenty of pure functions that operate within the tools. But we don't really use point free for that, kind of a general theme. And they're typically much more lightweight. They don't really need to access shared data. They're kind of just more like little one-off computations. Another big thing is, our architecture honestly is not perfect, but it's pretty decent. But that doesn't mean it's perfect over time. Because, I don't have a screenshot of it, but over the past month, I think we had about 168 merge pull requests into our code base that represented about 20,000 line of code difference. It's a lot of change over the course of a month. And whenever you're changing things at that pace internally, things are going to fall through the cracks. So as an example, this is from Perfview. It's a really shitty UI, but it's a really powerful tool. Only works on Windows. I hope they make a cross-platform version of it. But I got curious, and this is what we do. We get curious from time to time, and we say, okay, let's take a snapshot of some editing time in the IDE and just kind of see what things look like. And there was 1.1 gigabytes of strings and 4.7% of total CPU time spent on this thing right here, error resolution hints plus filter predictions. That's .NETism, but filter predictions is the name of the function. There was a lot of stuff going on in there. And this was actually a feature implemented a while ago by the compiler that was sort of meant to help users to say, oh, did you mean to type this? Because the compiler knows all sorts of names, and if you just mistype something, especially if you're not in an editing environment where you have auto-completion, it's a helpful feature. But it was running ambiently, and we could just kind of never really thought about what the tooling implications were when that was built. And sure enough, it showed up. And so we fixed it, and straightforward, and seemed kind of obvious in hindsight. But when things are changing at the pace of a very, very large code base, this sort of stuff happens, and so it's very critical that measurements are taken as a spot check all the time, just to sort of see where things are. Speaking of architecture, everything is asynchronous and cancelable inside of our tooling. And we make a big distinction between syntax and semantics as far as tools go. Syntax is about structure, semantics are about meaning. Any operation that depends on structure is fine. It's free-threaded. We can spin off as many threads in any way that we want. It doesn't really matter. Semantics, unfortunately, do matter. And these are actually single-threaded right now. And there's some approaches that we're doing right now to sort of improve that. But there is sort of a fundamental trade-off going on here, because F#, like many ML languages, does not just have local type inference, it has global type inference. And so you can have a project-to-project dependency graph. You know, A depends on B, depends on C, depends on D. You change something over in D, and all through that chain, it eventually makes its way over to A, and A uses that, but it doesn't have an explicit type signature. It relies on type inference. So semantics have changed if you change something in D. So what do? If you have concurrent requests coming in saying, hey, give me this semantic information, and we know that something changed, if this concurrent request here, there's sort of a question, okay, do we give false information or potentially false information, or do we wait and give correct information? So we said, okay, well, we probably want to give correct information. But then if you have something running concurrently, but it's just waiting on something that's single-threaded, there's kind of no point in it being concurrent. So it's single-threaded today. Now, we're doing some active, I guess, research, you could say, in terms of adding a much higher degree of concurrency with some heuristics based off of immutable snapshots that we can take at varying times and things like that. But this is the current state of the world. So speaking of the asynchronous and cancelable stuff, the computation expressions that I showed earlier actually come in real big handy here. These are used prolifically throughout our code base. Async maybe, this is, well, this is monadic asynchronous operations could give you something back, could not give you something back. And then this cancelable one, I haven't really thought about if that's technically a monad or not. I don't really care, honestly. But it gives you, it basically gives you, okay, this basically says everything that's inside of this scope is considered cancelable at any point in time. And it's just an easier tool to manage that complexity, because the only other alternative is to thread an object called a cancellation token as a parameter to everything. And we don't really like doing that. So, there's also impedance mismatches that go on that we have to deal with, because we're plugging into Visual Studio, a massive enterprise product. And when I say massive, I mean like the Git repo, zipped up, is more than 2.5 gigabytes in size. That's how much code there is in this thing. That's how big this thing is. And F# is a prominent piece of it. In fact, it's installed by default. You have to go out of your way to not get F# installed with Visual Studio today. So that's pretty cool. But that code base has been around for a long time. A lot of that stuff has been around since the late 90s. So, but you still got to work with some of it to some degree. Oh boy, this makes me sad. So we have this feature called Navigable Symbols. Basically, inside the editor, you can hold your control key. You can configure it to be any key, but typically it's the control key. And you can click on a symbol, or you can hover over a symbol and it'll turn into a link. You can click on it and it'll go to definition. It's kind of neat, right? Well, there's an API that we have to plug into to basically say, oh, what symbols are considered navigable? What do I do when somebody initiates navigation? So we define this type. It has to adhere to an interface, iNavigable symbol, some OOP stuff, but it's not too bad. There's the navigable symbol, but the bad one right there is, see that allow null literal attribute up top? Because you can't actually return null, as you can, oh, I have this type, and I'm going to return null as, the return type. You can't do that by default in F#. We don't actually let you do that. We made an error that says so-and-so type does not have null as a proper value. But you can opt into it if you have to with this thing right here. This part is even worse. See this thing that says let mutable disposed? This means that the component that we're working with could be disposed by the host, and we can't really have a say in that at all. And they have a recommended pattern for working with it, which is, I didn't show it, but there's another thing that could potentially set that flag to true. It's set to false by default, and if it happens to be true, then we just return null. And this is like I hate this thing so much. But we cannot have this feature unless we do this, because the underlying stuff works that way, and we couldn't just change it. There's no way around it. So we have to say, okay, like, do we deny this feature that people want because we didn't like the way the code was written? That's kind of a very silly proposition that no, enterprise customer is going to take seriously at all. So you've got to do this. So just kind of in summary, if you have to work with old native APIs, you're probably not going to be able to reconcile that with FP. Same thing with OOP. Like, there's some, I don't know, I think there's probably some Scala people out there who are like, oh yeah, you can mix OOP and FP really well. I don't really believe in that, even though that's a little strange, right? Coming from someone who works on a functional programming language that sits on top of kind of an OOP runtime and has OOP constructs. But I don't really think they're reconcilable. And that's just a fundamental impedance mismatch that you might have to deal with if you're in that sort of situation, period. Totality, you're going to violate it at some point if you're working at the, kind of an enterprise scale, or if you're doing things that enterprises require you to do. Same thing with purity. You're going to violate it at some point. It's going to happen. You got to know what to do about that. And hopefully it's not too bad. I don't think it's too bad in F#. So overall takeaways for all of this: F# is a case study as a product at Microsoft. I don't really know how generally applicable all of these things are, but at least this is sort of, if you can avoid scope creep and evolve things conservatively, if you're like an author of a component, or if you're an author of a language, that's even more cool. That is an excellent tool for keeping things stable and supported, which is really, really going to matter if you want something to live long-term in a larger organization. Support licenses really, really matter. Do not underestimate this at all. Even if you never have to support anything actually, just the fact that you have a license will be the difference between somebody approving something or not, right? You may be able to get buy-off on your entire engineering organization to adopt something and do it really, really well, but then CTO up top says, all right, how supported is it? And they go, oh, well, it's fine, we'll figure it out. That's typically not going to be a good answer. So you need to have some sort of answer for support, period. That's arguably probably the biggest one. I don't think we actually changed anything yet, even though we have a support like due to somebody saying, hey, we need you to change something based off of support. I don't think we've actually taken a concrete action that modified the language or the tools in any reasonable way. But the fact that we have it matters to a lot of our customers. High quality tooling, you need it, period. There's no, you're not going to convince enough people at a large enough scale to be able to use something if your tooling sucks. Because a lot of people care about their tooling a lot more than they care about their language. And you may be able to even convince them on the language side, but if they struggle to use that language, once they've gotten over the hump of learning what it's all about, and they struggle doing the things that are right in the language because the tooling doesn't support it well enough, they're going to want to abandon it. So everything needs to perform well. You need to always spot check things from time to time, even if you've got a really beautiful architecture. Because I guarantee you over time that architecture is going to have some flaws that are going to be pointed out. And you're going to have to learn how to deal with impedance mismatches at some point. I think that one kind of goes without saying for anybody who does major development work or component authoring and that sort of stuff. But I wanted to call it out mostly because we have a rather extreme case of it inside of our tools, and I kind of hate it, but it's what I live with. So anyways, that's sort of that's my whole spiel. I'd like to say thank you again for listening to me ramble on about this stuff. And I'm happy to take any questions that you have either now or later. So.
I have a question.
Yes.
What's the future? You kind of talked about how the past has been with all this work on Fsharp and all the compilers, all the tool chain.
Mm-hmm.
Where are y'all headed with Fsharp? Where's that sneaky stuff?
Sorry, I had to swallow my water there. So I have two answers to that. The first one is snarky. I don't know. No, but the second one is real. So because we are open source and cross-plat, that's something that, so traditionally Fsharp has struggled by being Windows only. And that was because the Microsoft of old was kind of not doing the right thing. The Windows 8 craze was just insane. And like it kind of, like it's one of those things that, I don't know, I think they were correct in that they were like, oh, we need to reinvent the desktop OS because the desktop, these mobile devices are coming in, different form factors, we got to do with that. They were like, all right, cool, they identified the problem, but they needed to go this direction and they went this direction. And that was all about, oh, everything has to be Windows, 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 Windows. And the fact of the matter is there's a lot more developers out there who are not on Windows than developers who are. And although there are lots of Windows developers out there, you don't want to constrict yourself to that. So we prioritize .NET Core and cross-plat. And I think due to that, a lot of the community has done web services and just cloud programming, and I think that's kind of been sort of natural with the fact that you could run on a Linux machine, and kind of everybody, even if they're a Windows shop, gets management pushing them to say, hey, use Docker. And if you want to use Docker, like, don't use it on Windows. So Docker for Windows sucks, like, I'm sorry. So in light of that, like that, we didn't really push that. We were like, okay, the community sort of did that, but what's something we can do? Well, I think a lot of people really love the promise of WebAssembly. I don't know if WebAssembly is like the thing, but I think the promise of it is so good that so many people are excited about it. So we do have actually Fsharp support running on WebAssembly, but I think the WebAssembly, it's kind of experimental, so I wouldn't like actually depend on it. But I think WebAssembly is at the point where, okay, if we as an industry if we actually want it, and we want it to be real, we need players like Microsoft to start throwing a lot of money at it. And so we are. And so we want Fsharp to be part of that. C# is also part of it, but we definitely want to focus on that. I think it's an interesting problem space, and a lot of people seem like they're interested in it. Beyond that, Fsharp for machine learning is also kind of a big research area that we have. I might actually, well, I don't know if I'll pull it. No, I won't pull it up. But if you Google or Fsharp TensorFlow, it's a research project that we have where we basically offer kind of like static type checking for TensorFlow. We can't actually really do that because we tried to figure out what a proper type system for TensorFlow would look like, and it ended up needing to be dependent types, I think. So we don't have that in Fsharp, so we couldn't do it. I mean, we could go offline for years and implement dependent types, but that would mean dropping everything else. So, but one thing that TensorFlow does do is it can be executed at what's called design time, where where they do have APIs where you sort of like have like a level of TensorFlow evaluation to see if like shapes match, so like shape checking. So we can actually plug into that and tie that into the Fsharp type system, and that works really nicely with type inference because as you pipe data through your pipeline and that pipeline transforms the output shapes, and you pipe that into another thing and you did it mistakenly, like maybe it needed a dimension of 128 and you accidentally sent it a dimension of 64. Well, the difference between 128 and 64, like from a type system standpoint, is shitty, right? Like you don't want to be forced as a compiler to have to keep these integer values in your head all the time. So that's sort of, I think, the two major areas now. Yeah, at least as far as what we're doing. Another strategic thing, honestly, is stepping back. So I think Microsoft has had a problem in the past of trying to like own the narrative for everything. And if you look at probably one of the biggest examples of success out there, the web with browsers, like, I mean, JavaScript's a shitty language. It has horrible semantics, honestly. Like, yeah, okay, it's got first-class functions. You can like morph it into something that can be kind of nice if you really do it, or you use a different language that effectively has a transpiler for JavaScript. But the underlying semantics of JavaScript are not that good. But it is the most successful programming environment. Like there's the phrase, always bet on JS. It's not always bet on the language, it's bet on the ecosystem because no other ecosystem is nearly as good as it. And that's because nobody really owned the narrative behind it. It was just a bunch of crazy weirdos building all sorts of cool, interesting stuff. And through that chaos emerged like this incredible ecosystem. And I think we want more of that for .NET as a whole and certainly for Fsharp. So, because that's, yeah.
I feel like .NET doesn't ask the whole, it's Microsoft's thing, so let them deal with it.
we're trying, I mean, we want to control certain things because we don't, we want to control the compiler stable, that sort of stuff. But yeah, but like as far as determining what you should do as a developer, at least me and a lot of my colleagues are like really hate that idea. because it's like it's like, oh, like we know better. Like that's just ridiculous. So we definitely want to step away from that. So at least I try to emphasize that a lot with Fsharp. I actually had a long-term Fsharp developer who's like a really big fan of Windows, call for me to get fired because I basically punted on what's called UWP, or Universal Windows Platform, which is not universal. It only works on Windows, but it's called UWP. And it was an effort that was started by the person who was kind of in charge of Fsharp. And I was like, okay, this thing is like limited to Windows 10 only devices, like whereas the cross-platform thing reaches so many more people. Screw this thing. And yeah, I actually got somebody on Reddit was just like, I'm gonna call to get you fired. I'm gonna email Scott Guthrie, who's my executive vice president. We're gonna get you fired for this. I'm like, okay. So at least I know my executive vice president would have just kind of laughed at that because he'd have been like, okay, some crazy person wants to fire an employee, whatever. But
you mentioned dependent types. Is there any relation between Fsharp and Fstar? Like is there some sort of discussions, or maybe the same people working on it together, or anything like that?
Yeah, there are quite a few. So Fstar, I mean, we all share the same ML heritage. Fstar is implemented partially in Fsharp, and they did take some of, I don't think they do computation expressions at all, but they do basically our record and union types. They basically just lifted those and said, oh, well, we use those and then we'll modify it a little bit. Because I think Fsharp came before Fstar, and so they were able to sort of fork the code base and kind of go off in their own way.
I thought it was like, does Fstar like compile to Fsharp or something like that?
It can compile either to Fsharp or C. Which is interesting, but it's very heavily a research project though. But it's pretty cool. It's like I do like using it, just kind of playing around with its dependent types because I don't know, I really love ML like style programming, and having that work with dependent types in your type signature just feels nice to me. So yeah.
I guess. Well, I'm just gonna throw one thing real quick is that, and then something I found interesting was that the tooling. APIs are actually built into the compiler.
Yeah.
So does the compiler support like partial parse trees and stuff like that? So your tooling still works even though you don't have a proper parse tree?
Yes. Yeah. Well, what we do is we construct a parse tree based off of everything that we can. And the fact that it might not type check is sort of unimportant at that point. Right. So we create the structure for everything, and so that allows even things like code outlining and collapsing of scopes. Even if those scopes are utter nonsense, you can still do that. Now, if that part fails to parse, then we can't move forward from there. But we can do sort of
like recovery, maybe.
Yeah, we do a lot of recovery. There are some niggling issues with that. So like sometimes it doesn't work perfectly, but by and large, I'd say certainly for a given scope, if you have a parse error there, following scopes are usually fine. And so
that's amazing. That's in the compiler.
Yeah, it's a lot of work to deal with, but I like it though because whenever I talk with people who deal with Scala tooling or Haskell tooling or other things, they're like, oh, the JetBrains compiler didn't work, or like
don't use GHC's parse trees.
yeah. So like that's the sort of thing that like we took that as like a philosophy. We're like, okay, we can't live in that sort of world. So that's yeah, it's fun too. Yes.
As an Fsharp user, I'm very grateful to you and Microsoft. I love your candidness.
Thank you.
I love the recent anonymous records. It's so cool. I want to put in a quick plug, if I can, for my Fsharp talk tomorrow, 4:30. Type providers.
Absolutely.
And I did have one question.
Okay.
Maybe you don't want to answer this question, and I think I know the answer somewhere between no and hell no, but I don't know. I'll ask.
Maybe.
Okay.
That was better. Yeah, I think you asked that question 2 years ago and I said no. And now I think the answer is maybe. And the reason why is because you can already do a type class like encoding today in Fsharp, but it's like not really first class. So like that we didn't want to go further in that world because it relies on static constraints that the runtime doesn't understand. And we were saying, okay, well if the runtime eventually adopts something that could support type classes, and we have this thing that the runtime doesn't understand, well, we just created a really big problem for ourselves. Because now we have like this isolated component for doing things that is not well known by the underlying runtime that we're supposed to be a part of. So
why does the runtime, I mean, should the compiler just insert it as like an extra argument into the function signature or something?
So we could do something like that, but then it would be like, it basically incurs a significant, well, not significant, but depending on what you're doing, it could be a significant amount of overhead, but it incurs overhead by doing it that we don't want to do, especially if, say on the C# side, they do some type class light sort of thing, which they're actually considering. Not full type classes, but type class-ish, but the runtime will fully support everything that we would actually need. Nobody's worked on it yet, but it is actually something that's being planned.
What does it mean for the runtime to support it, I guess?
So it's just like a first class construct, similar to how...
so you can like summon it at the
yes,
level?
exactly.
Oh, yikes. Okay.
And so because it can't do that today, that's, you know, we'd have to construct some sort of facade that was over the top of that.
On .NET, right?
Yes.
So that's different than like, okay.
So that's sort of the route we're going. So we are, I think it's an eventuality that will happen at the runtime level, and when that happens, we're gonna surface that in Fsharp, and we're probably gonna build on top of it. I would actually personally like to see higher kind of types implemented, you know, just sort of with the whole bucket. Type classes, HKTs, they oftentimes come together in other languages, so I would like to see that too, but I don't really have a concrete sort of guide for that, so the answer is maybe. That's better than 2 years ago.
Maybe next year will be definitely.
Yes. Cool. Well, that's just about it. Everybody get their lunch. I'm sorry I kept you a little bit later. I said I wouldn't do that. Thank you.